Hey guys, welcome to this session by Intellipaat. So have you ever wondered how these giant IT organizations store their data? So these organizations uses different databases like Oracle for transactional data, MySQL for storing the product data, and many other for different tasks. So only storing the data is not enough. You need to analyze the available data and need to extract meaningful insights from it in order to understand the customer's behavior. So for that, organizations started using Hadoop. In 2006, Facebook switched from Oracle database that uses SQL queries to handle the database to Hadoop that understands only MapReduce. So this became a redundant task for them to handle the database. So they needed an interface that can convert SQL queries to MapReduce programs, run it in a cluster and show you the result. So this is where Hive comes into the picture. It is an interface created by Facebook that converts SQL queries to MapReduce programs. So, in this session, we'll learn Hive comprehensively. Before going ahead, subscribe our channel and press the bell icon so that you never miss out on our upcoming videos. Also, if you want to be a certified professional in Big Data Hadoop, so I would like to suggest you a certification course by Intellipaat, which is Big Data Hadoop Architect course. Now let's have a glance at the agenda. We'll start off by understanding what is Hive. Then we'll see the difference between MapReduce and Hive. After that, we'll look at differences between different types of Hive and look into the features of it. Then we'll move on to Hive interface. Going ahead, we'll see the partitions and indexing in Hive. And finally, you can put down all your queries in the comment section. We would love to help you out there. So without much delay, let's start off with the class.
What is the requirement of Hive? You have this guy called RDBMS, right? So let's say you are using MySQL and you are also using, let's say, MS SQL, that is Microsoft SQL, right? And you are also having Oracle. So your organization, let's say, uses 3 databases, right? Now, why are you using 3 of them? I don't know. Maybe you're using Oracle for transactional data, payment, etc., etc. Maybe you're using MySQL to store product catalogs, etc. Maybe you're using Microsoft SQL for some other purpose. So, but just assume that you are having 3 databases, right? Real-time databases. Now, these guys are called RDBMS or database, right? And we also call them a name called OLTP. They are online transaction processing systems. Now, I know that this is too basic, but I'm just trying to give you an idea. So every organization has multiple OLTP systems, maybe single OLTP systems deployed across the world. Now, your manager comes to you and says that, hey, so let's say I'm the employee, so my name is Raghu. Hey, Raghu, we want to do something. You know what? We want to just collect the data from all these databases, and I want to create a nice report and show to my CEO so that I can get a free holiday. So I can impress my CEO with my nice report and all, so I can get a free holiday. Maybe you get a salary hike also. So why don't we pull all the data from these systems and put it into a place and practically create a report out of it? Now, you have guys known as business intelligence guys, BI. So business intelligence is a part wherein you get data and you make sense out of the data. Given any type of data, you can create nice charts, pie diagrams and reports, etc. using business intelligence. There are a lot of BI tools available in the market. For example, we have Pentaho BI, many tools are available, right? So I thought like, all right, so let me do one thing. Let me take a business intelligence tool, which can create nice reports and all, and let me install it on my Oracle. Let me also install the tool on Microsoft SQL and MySQL, all 3 databases. But this doesn't make any sense. Why it doesn't make any sense is because you see all these databases are real-time databases. That is why we call them as OLTP. And they are serving your customers in real time. I don't want any unnecessary load on these databases, right? So if I install a reporting tool on top of it and start digging the data, it may impact the performance of these databases. So I don't want to do that, right? So what I I do is I bring in the elephant in the room, and that is, my friends, your data warehouse. We call it as DW. You can also call it as OLAP, Online Analytical Processing System. So using ETL, you bring data from your RDBMS systems into your data warehouse. So technically what is happening is that using ETL tools, ETL is extract, transform, load, right? You can take data from your RDBMS systems and dump it into a place called a data warehouse.
Just a quick info guys, if you want to become a certified Big Data Hadoop architect, Intellipaat offers you a complete Big Data Hadoop architect course which covers all the major concepts. So for further details, check the description below. Now let's continue with the session.
Now, data warehouse is a fancy term actually. It's not a fancy term, it's a technical term. What is a data warehouse is nothing. Data warehouse is a place where you store, first of all, massive amount of data. Point number one. Point number two, this data is ready to be accessed, ready to be reporting. So if I have a BI tool, my BI tool can be directly installed on my data warehouse and it can produce nice reports, etc., etc. And a data warehouse is internal to your company. You don't have public access, because this is your private storage. I'm collecting all the data and dumping into this guy so that this guy holds the whole data, and now I can do whatever I want with my data. Very simple. Organizations were doing this for quite some time. If you go to any enterprise organization, what they do is that they will have multiple OLTP systems. They keep on collecting the data, nightly cron jobs or whatever you want, and then dump it into a data warehouse, right? Now the data warehouse will hold historical data. So this guy has historical data, meaning it will have this year data, last year data, last to last year data, a lot of data, right? And on this data, you can do whatever analysis you want. Very simple. So data warehouse is a place where you store massive amount of data ready for analysis, and you do not typically have public access to this thing, right? And that is. Now, if you look at the players in data warehouse, you have many companies who are doing this. There is somebody called Teradata, which is a major player actually. You also have Oracle Exadata. These are all data warehousing companies, okay? You have SAP HANA, you have Netezza, Greenplum, etc., etc. These are all data warehousing companies. So in your organization, if you want to implement a data warehouse, what you do is that you go to, let's say, Teradata and say that, hey, Teradata, you know what? I want to implement a data warehouse in my company. So Teradata says, all righty, take this and go. So they will give you practically an appliance, like a box, which you install in your company, and then you can load it with data. It stores, you analyze the data. So the question is, why am I talking about this? What is the big deal about this? See, there is no big deal about this, but so far, whatever I was discussing is how the world was working. Now everything seems nice here. Okay, nice. We have OLTP systems. We take ETL. We dump the data to data warehouse. We produce reports. Nice and happy. But only one major problem. And the problem is this: dollar, 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 money, money. Okay, the problem is cost aspect. Data warehousing is a costly affair, to be honest with you, right? For example, if you want to implement a Teradata solution, it will cost you millions of dollars, practically speaking. It is not so easy. Also, it is not so cheap. People who are working in the data warehousing background will be able to comment on this, but data warehousing is a costly affair, right? So that is the backdrop. That is the history that we are talking about. Now enters Hadoop. So here is your Hadoop cluster. So what is this? Your organization has a Hadoop cluster. Now imagine your organization already has a Hadoop cluster. Fine. What is the problem? In a Hadoop cluster, obviously you can store big data. Right. But what happened was that somewhere in 2006, the company called Facebook got interested in Hadoop. So Facebook was dealing with this big data problem. So basically, Facebook was in the growing stage in 2005, 2006, etc. And Facebook was getting a lot of users at that point in time. And Facebook was thinking that, you know what, everything is working fine, but we really don't have a solution for storing big data and analyzing big data. And Facebook was running completely on Oracle. Oracle was their prime backend actually, and Python. Python plus Oracle, that was Facebook's initial architecture, right? Now, somewhere in 2006, somebody told Facebook that, hey, you know what? Why are you so worried about storage of data? There is something new in the market called Hadoop. And if you implement the Hadoop cluster, you can store unlimited data practically because Hadoop is naturally the solution for big data, right? So Facebook got interested in this idea and they immediately implemented a Hadoop cluster. So practically speaking, the entire data that Facebook was storing and analyzing, they moved into Hadoop. But what was the problem? Back in 2006, we were at Hadoop version 1 or the old Hadoop or the original Hadoop. And you know what? The original Hadoop had only map reduce. That means if you want to interact with the data in a Hadoop cluster, the only way was that you must write a map reduce program, right? You have to write a MapReduce program. This became a problem for Facebook because every day Facebook needed to fire 70,000 queries, SQL queries. The requirement of Facebook was that every day they had to fire 70,000 SQL queries on their data. And this was working when they were having Oracle. Even though it was slow, they were able to somehow manage because Oracle is a typical RDBMS. You can easily write 70,000 queries. Now, what happened all of a sudden, the whole data is moved into Hadoop, no more Oracle. So the developers at Facebook faced a serious problem. The problem was that now the entire data is in Hadoop. Hmm? And Hadoop doesn't understand SQL. Hadoop never understands SQL. What Hadoop understands? Hadoop understands MapReduce. And if you want to write a MapReduce program, you have to learn Java, you have to write your program, you have to compile it, create a jar file, deploy it. It's not easy. If you're a SQL developer, trust me, learning Java is not going to be so fun for you, right? Because SQL developers, we tend to be, more towards the SQL side of the spectrum. We don't really are not programmers, right? So all of a sudden, all the employees in Facebook started complaining. They said that till yesterday, our SQL queries were working on the data. Today, when I write a SQL query, I'm not able to run the query. What happened? So Facebook said, guys, we just moved everything into Hadoop. Well, that's not justice. That's not just, right? So in Hadoop, you cannot run SQL query or you were not able to run SQL queries. Then what was the alternative? The alternative was to write a map reduce program for a SQL query. And that's practically madness because for a simple select count star query, you have to write 100 lines of code in Java and compile it. And imagine 70,000 queries. So what Facebook did is that they thought, all right, we need a solution for this. We have a lot of structured data in Hadoop, but unfortunately, our developers are not able to access the data. So what we can do? And thus, Hive was born. Hive was created by Facebook. Later, they donated Hive to Apache as a top level project, but the first Hive version rolled out from Facebook. So the next big question, what exactly is Hive? Imagine you are storing some data in Hadoop, storing structured data. Let's say you're storing a data called sales.txt, a text file called sales.txt. Imagine. And imagine this text file has a structure like comma separated values, imagine, so they are having order number, product ID, blah, blah, blah. It's a very big file actually. You store it in Hadoop. Now, if you want to analyze this file, you can write a MapReduce program. Or what you can do, you install Hive, right? Now, Hive will give you a shell or a command line. You write SQL on the Hive's command line, right? You say select count star from this table. You write a SQL on Hive's command line, hit return, meaning run the query. What Hive will do, it will convert your query into a MapReduce program, run it in the cluster, and show you the result. That is Hive. Hive is a SQL interface on Hadoop, and it is the default data warehousing framework on top of Apache Hadoop. So what is a data warehouse? A data warehouse is nothing, a huge storage with a SQL interface. Data warehouse is huge storage with SQL interface. Now you already have Hadoop, which is huge storage. You install Hive, you get a SQL interface. You practically create a data warehouse with zero investment. That is the advantage of Hive. Hive is free. You just install it. You can start writing SQL and you can access structured data using SQL. You can do all your regular operations, creation of tables, left outer join, right outer join, group by queries, blah, blah, blah. That is Hive.
Just a quick info guys, if you want to become a certified Big Data Hadoop architect, Intellipaat offers you a complete Big Data Hadoop architect course which covers all the major concepts. So for further details, check the description below. Now let's continue with the session.
Now, what is the difference between Hive and HBase? Now, Hive is what we are seeing right now. HBase is your default NoSQL database on top of Hadoop. But remember, HBase is the default Apache NoSQL database on top of Hadoop, right? The real question is that why somebody should use Hive? You should use Hive. Say, for example, I don't want to learn Java. I don't want to learn MapReduce. I'm not a programmer. I know SQL. Then Hive is your choice because it just understands SQL and it'll automatically convert that into MapReduce so that you don't have to sit and learn Java and MapReduce. You write your logic in SQL and it works. Imagine you have what you say an Android mobile phone, right? Now what happens is that in the Android mobile phone, when you're buying a mobile phone, obviously, right, you get a default, what you say, calling option, messaging option, etc. You can call people, you can text people, you can do a lot of things with an Android mobile phone. But you can also download apps. For example, if I want to catch a taxi, I will download and install Uber. If I want to check WhatsApp, I will download and install WhatsApp. Similarly, Hive is a tool which you have to install on top of Hadoop. So that is why it is called as an ecosystem tool. Ecosystem tool means tools which can be installed on top of Hadoop. Think about Hadoop like your Android operating system and Hive like Uber app you're installing on top of that, right? So Hive can talk to Hadoop. It gets installed on top of Hadoop. Point number one, right? Now, another point, where is Hive, right? So the first question is, where is Hive getting installed? Is it inside the cluster? Is it outside the cluster? Is it on top of my head? I don't know, right? Where are you installing Hive? So I have a Hadoop cluster, right? Now the point you have to understand is that Hive doesn't have any storage. Hive doesn't have any storage. For example, let's say you're copying a data. So I'm copying a data called, let's say, transaction.xls. It's a spreadsheet. I'm copying a file called transaction.xls. Now what happens in my Hadoop, this gets divided into blocks in data nodes. We are all familiar with this, right? When you copy the data, what happens? The data gets divided into blocks on my Hadoop, right? So in Hive, when you say create a table and load the data, Hive will refer to this data which is lying as blocks on your data nodes. It doesn't have its own storage. Very important point. So Hive is just giving you a projection of your data. Your original data is lying as blocks in data nodes. And when in Hive you say create a table, you're just giving a structure to the data so that you can see the data in the form of a table. Clear? So Hive doesn't use any storage, right? The second point you need to understand is that if I am sitting here okay, and I have a laptop or a desktop, Hive is a client-side application. For the time being, I will explain more about this, meaning Hive gets installed on your laptop, not in the Hadoop cluster. Now there is a slight variation to this, but for the time being, let's assume like this. That means, and your laptop is obviously connected to the cluster. You will have Hadoop client libraries, so your laptop can access the Hadoop cluster. So Hive is a client-side application. That means you install Hive on your laptop, open the Hive shell, you will say create table, and you will give some schema, whatever schema you want. Okay, then you will say insert the data into the table. Now, what is this data you are inserting? This data is these blocks. That's what I'm saying. You are not inserting anything. When you say insert the data, Hive will just refer to these blocks in your Hadoop. And then you say, do a group by query or some SQL query. What Hive will do, it will generate the jar file, right, and send it to the Hadoop cluster. So for Hadoop, there is nothing called Hive. For Hadoop, it is just a MapReduce program. Let's understand that Hive is a client-side application. That means you install Hive on your laptop. And why are you installing Hive on your laptop? Because you don't know MapReduce. And you are a SQL developer. And you know that there is structured data in Hadoop. You want to create a table out of the data and do the queries. So you install Hive on your laptop, say create a table, load the data, write your query, hit enter. Hive will automatically write the equivalent MapReduce program, create a jar file, send it to the cluster. So from the point of view of the Hadoop cluster, it is a regular MapReduce program. It's not Hive. Hadoop doesn't understand Hive. Hadoop understands MapReduce. So either you can write MapReduce, create a jar, say run. Or you write in Hive, Hive is also going to create a jar and say run, same thing. That means Hive doesn't have its own storage or anything. It is just accessing the data in Hadoop and giving a projection. So that it is easy for you to work with. Now, you cannot work on blocks or data nodes and all. If you can see your whole data in a table, it's easy for you to write queries, right? And that is Hive giving you. It is giving you a projection of structured data stored in Hadoop. That's it. So Hive understands your SQL, even though Hive's language is called Hive Query Language, or we call it as HQL. It is pretty much similar to SQL. So that means if you're a SQL developer, you know SQL queries, you can easily start working on Hive. Introduction of Hive. Hive is a data warehouse infrastructure that is built on top of Hadoop. Hive provides a mechanism to project structure on the data using SQL-like language called HiveQL. Hive uses MapReduce and HDFS for processing and storage retrieval of data. Now that we understand, the data is an HDFS, processing is done by MapReduce. Now there is a small point here. It's not exactly MapReduce, right? But for the time being, let's keep it as MapReduce. The advantages of using Hive, it can be used as an ETL tool in the sense you can bring data to a Hive table, modify the data, store it as permanently. It provides capability of querying and analysis. So Hive is actually used by the analyst community who is very good at SQL, can handle large data sets, and you can do filters, join, group by, all these SQL queries on top of map and reduce. Now, if you ask me, can I see the MapReduce code created by Hive? No, you cannot see. So the MapReduce code created by Hive is not visible. You will just get a jar file. You won't even see the jar file. You will see the jar file running, right? Now, the most important point you have to remember is that Hive is expected to be slow. It is slow because ultimately it is MapReduce. It's not like your Oracle or MySQL or something, because in any RDBMS systems, typically when you write a query, you will expect the results within microsecond. In Hive, when you write a query, sometimes I have seen queries taking 4 hours, 5 hours. Why? Because, it's just an illusion. Where not to use Hive. So this is very important point, where you should not be using Hive. Hive should not be used if the data does not cross gigabytes. That means if you are not having big data, why are you using Hive, right? You can stick with your traditional tools. If we don't find schema or bringing in schema is difficult or not possible. Now the point is that when you access Hive, you have to create a table. Hive works on the concept of databases and tables, right? And whenever you're defining a table, the table should have a schema. Now, if your data cannot fit into the table, there is no point in loading the data. Let's say you're getting some type of data. Let's say you're getting text data, raw text data, right? Now, in that data, you're not able to find a structure to the data. Imagine, I'm just saying you imagine. Imagine you're getting raw data, plain free-form text, right? So in free-form text data, how do you find a structure? You cannot find a structure. That means you cannot use Hive on top of that data. So you have to use Hive where you can find some structure to the data. Maybe you have comma separated values, space separated values, column separated values, something, or JSON files, XML files, even semi-structured data. They can all fit into Hive.
Just a quick info guys, if you want to become a certified Big Data Hadoop architect, Intellipaat offers you a complete Big Data Hadoop architect course which covers all the major concepts. So for further details, check the description below. Now let's continue with the session.
Now the next case is if we need response in seconds and low latency applications. I told you Hive is expected to be slow. And if you are looking for a faster solution, don't use Hive. If RDBMS can solve, don't invest time in Hive. Very important point. Hive is not a replacement for RDBMS or something. Okay, because RDBMS systems are real-time systems and Hive is not something which can replace them. If your RDBMS can solve your most of your problems, then don't use Hive. Hive is specifically for huge amount of structured data. Say you want to create a table, size of the table is 3 terabytes. Very good. Do it in Hive. Query the table. Your SQL will be very easy. Even though it takes some time, you will get the result. That is where your Hive's use case will come. So think about Hive like a translator. It's a translator. You write SQL, it speak MapReduce to Hadoop, right? And Hadoop gives the result, it shows as a table to you. So for you, the developer, everything is SQL and table. For Hadoop, everything is MapReduce. And Hive stands in the middle. Now, what is the similarity with SQL and difference from SQL? Hive is very similar to SQL-like queries. It is based on actually SQL 92 framework, and it is safe to say that its functions are mostly same. What is the difference from SQL? The major difference is that Hive query executes on Hadoop rather than traditional database. That means you cannot install Hive outside Hadoop. It works only on HDFS. This allows Hive to scale to handle huge data sets, which cannot be done by RDBMS. The internal execution of a Hive query is via a series of automatically generated MapReduce jobs. Right? So the next question naturally you will have is that, oh, I understand Hive, but can I fine tune Hive? What about performance? Can I improve the performance? Can I do something with Hive? Yes, you can do. Now all Hive queries will be converted to MapReduce job. So why can't we write MapReduce ourselves? So this is one question people ask. See, Hive is converting everything into MapReduce. So why don't you just write MapReduce for God's sake, right? Why are you using Hive? Understanding the internals of Hadoop framework is must to write MapReduce. SQL engineers can quickly write Hive scripts. Now, if you want to write MapReduce, right, you have to learn Java or Python or Ruby or C Sharp, right? Then you have to implement your logic or using MapReduce framework. You have to write your custom mapper, custom reducer, package it as a jar file, resolve all the complexities, errors. Now here, you don't have to do any debugging, anything. Create a table, write your query, and it just works. That is how it works. So the next point is that now talking about the real world. Okay, so let's suppose you learn Hive. in our Intellipaat course, and you master Hive. And what did I teach you? I taught you that Hive is a SQL interface to Hadoop. Fine, you understand that, right? And then you go to a real world project, okay? And then you go to the project and say that, you know what, I'm an expert in Hive. Hmm? An expert in Hive. I know Hive really well. You want to say to your project. And these guys are going to tell you that, you know what, you can use Hive, or you can use Hive plus this. You can use Impala. You can use Spark SQL. You can use Phoenix. What did I just do? I just blew your mind out of proportion. So when you go to a real project, in a real world project, and you ask them, okay, I have data on Hadoop, give me a SQL tool, they will either give you Hive, or give you Hive plus this, or give you Impala, or give you Spark SQL, or give you Phoenix. And you are like, oh my God, there is only Hive that is a SQL interface. Now I am in a dilemma because these guys are talking about this, Impala, Spark SQL, Phoenix. And trust me, if you write a SQL query, it will be executed the same way in all these platforms. You write a group by query, Hive will execute it, Hive plus Thais will execute it, Impala will execute it, Spark SQL will execute it, Phoenix will also execute it. So the real question is, what are these different tools, right? So this is some real world info to you guys, right? See, Hive is the original tool. This came first, right? So Hive is the first Avenger. So this is the first Avenger. So this is the first guy who came into the world, right? So when Hive came, everybody was happy. So people said, all right, fantastic. Now I got SQL interface. I can write a query, and you know what? The query executes nice. But over a period of time, people didn't really like Hive. People said like, all right, Hive is great. But the problem is that the queries are damn slow. You know, the other day I wrote a query, it took a day to give me the result. I don't really like Hive. We need something else. That is when, the company called Hortonworks started proposing Hive and Thais. Now what happens here is that if you access a Hortonworks Hadoop cluster, and you write a Hive query, say execute, the Hive query will be converted into Thais, not MapReduce. So original Hive is Hive plus MapReduce. Hortonworks Hive is Hive plus Thais. So what is Thais? Thais is a framework, Apache framework. Probably if you're interested, you dig deeper. Well, Thais is created to make MapReduce faster. So I don't want to get into details of Thais. I'm just giving you some extra information. For the time being, understand that Thais is a framework which is built to overcome the problems in MapReduce. MapReduce is ideally slow. MapReduce is normally slow, right? So some guys built something called Thais, and Thais also uses mappers and reducers and all, but Thais is much faster than your MapReduce, right? So Thais is a Hindi word. It stands for speed, and it is created by Indians. It is the next level of MapReduce, you can say. So what Hortonworks did, they said, see, what Hortonworks did, they said, why don't we club Hive and Thais so that queries are faster? Are you getting the point? So if you are on a Hortonworks cluster, you write a Hive query, say execute, you will see a Thais job firing. You will never see a MapReduce job firing because Hortonworks promotes Thais. Even though Thais is Apache open source, Hortonworks says they promote Thais, and they say that's their queries are faster. So your first Avenger, original Hive, is damn slow. Now Hive plus Thais, this guy is interactive. Interactive query means it is faster but not real time. So if you are writing a Hive query, on a Hortonworks cluster, it uses Thales as an execution engine, and it is faster, but it's not real time or something. It's kind of like faster. So when Hortonworks started this, even before that, there is another company called Cloudera. There is a company called Cloudera. Cloudera, what they did, they invented something called Impala. Impala is again built on top of Hive. Impala is a SQL interface, but what happens if you write a SQL query on top of Impala, it will run it using a daemon called Impala D. It doesn't use MapReduce, it doesn't use Thales, it uses a proprietary Impala D to run. So this is promoted by Cloudera, and this is also interactive. Now Hortonworks will say that Hive plus this is faster. Cloudera will say Impala is faster. That is a war going on for like past 4 years. Nobody knows. Both are same. But whether it is Hive plus this or Impala, it's again a SQL interface for you. Only difference, if you're on a Hortonworks cluster, the execution is done by Thales. If you're on a Cloudera cluster, execution is done by a daemon called Impala. And there is somebody called Spark. Spark has a SQL interface that's called Spark SQL. If you write a query on Spark SQL, again same SQL, this will be converted into Spark, and this is almost real time. So this is faster. Look at this, look at this. Hive Thales, Hive Thales, SQL, Hive, Thales. But in Hortonworks, you can also say that I don't want Thales, I want MapReduce. They can switch the engine. So these are all additional information, extra information, but good to know things, right? So Phoenix is SQL interface on top of NoSQL. That means HBase is your NoSQL database, right? And HBase doesn't understand SQL. So if you do not know the language of HBase, you install Phoenix, you write your SQL query, it's going to convert in the language of HBase, show you the result. Original Hive plus MapReduce is batch processing, very, very slow. Thales and Impala are similar, interactive, but Thales is Hortonworks, Impala is Cloudera. That means you will never see Thales on Cloudera and Impala on Hortonworks. Spark SQL is again on Spark Framework. Phoenix is on HBase. Difference between different Hive. For example, you have something called Hive. Then you have something called Hive Server 1. Then you have something called Hive Server 2 plus Beeline. So what are these terms? What is pure Hive? What do you mean by Hive Server 1? What do you mean by Hive Server 2 plus Beeline? See, so this is something which you have to understand from the technical point of view. Originally, only Hive was there. And this is just a client-side application with an interactive shell, meaning the original Hive, what you call the pure Hive, is just a client-side application. That means if you are a developer, you take your laptop, install Hive, you get a command line. In the command line, you say create a table, drop a table, do the query, blah, blah, blah. It just works. There is no server, only client. And that is what I was explaining in my picture also, right? I drew a picture where I was telling you that, Hive is just a client-side application. So when Hive was invented, people were really happy. They said, oh my God, that's really great. So we can get a shell and we can write commands and we can work with Hive. That is nice. But later, people started thinking, so how do you connect your database? Can you tell me? You have an Oracle database. The Oracle database is sitting in some place. How do you connect it with the Oracle database or Microsoft SQL database? What do you use to connect? You need a client-side tool, something like MySQL Workbench or something, right? you need a client-side tool to connect using JDBC or ODBC, right? JDBC, ODBC connections can be made, but for that, yeah, you will have a server where Oracle is running. You need an Oracle client, some SQL client, right? So what people thought is like, okay, everything is nice about Hive, but I cannot connect to Hive from my SQL clients. Why? Because Hive was just a command line. Look at here. That is when Hive Server 1 came. This guy will allow JDBC or ODBC connections from your regular SQL clients. That means Hive Server 1 means there will be a server running in a Hadoop cluster. Clear? Hive Server 1 is a server which is running in the Hadoop cluster. You in your laptop, if you install Hive, you can open the command prompt and type queries. Or you can use your regular SQL client tools to connect to the Hive server and perform all the activities. Right? So Hive Server 1, the option is that you can create JDBC connections from your SQL client directly to Hive. So you can insert into a table, you can do whatever queries you want, you can directly run in your client. Very easy. You don't have to use a command prompt. You can use a command prompt also. So people were really happy. Hey, great, we have Hive server, we can connect, we can run queries, blah, blah, blah. But this lacked concurrency, meaning there was no concurrency or consistency in Hive Server 1. That means if multiple users create sessions to Hive, it was impossible to handle the sessions. Data persistence, data concurrency issues were there. That is where Hive Server 2 came. Hive Server 2, first of all, it also allows your JDBC, ODBC connections. It provides concurrency and it has a new client-side command line tool called Beeline. That is Hive Server 2. So Hive Server 2 is kind of like an upgrade to Hive Server 1. The basic difference is that it also allows JDBC, ODBC, but it provides concurrency. That means multiple JDBC, ODBC connections are possible. You can work with Hive, but they have redesigned the CLI of Hive, and the new CLI is called Beeline. Still, it supports the old CLI, and the new CLI is called Beeline. Beeline is actually a client which you can install, like SQL client. So I can go to a computer, install Beeline client. From there, I can make a connection request to the Hive Server 2 and start working in the Hive. So the Hive server will be installed inside your cluster. The architecture of Hive. Now you can see a person, okay, and he is using the Hive query language. Now you can, if you are a person, either you can interact with Hive through CLI. That is what I'm saying. CLI means it can be the Beeline client or regular command line, Hive shell. I will show you the Hive shell. It's an interactive shell. Or JDBC, ODBC. That means you are having a SQL client. From there you can connect. Or a web UI. Hive also provides a web UI. And whatever ways, look at the arrow. If you are using the CLI, directly you will be hitting Hive. That means hitting Hive in the sense, if you're using the CLI, you will be directly creating tables, etc., etc. But if you are using the JDBC, ODBC, these sessions are handled by Hive Server 2. So we are having Hive Server 2. So the main purpose of Hive Server 2 is to handle this multiple sessions that are created by users through JDBC, ODBC. That is why there is a difference in the arrow. CLI means you are directly invoking Hive. JDBC, ODBC means you're connecting through the Hive server. So either you use CLI or you use JDBC, ODBC. Now, where will I install Hive Server 2? It is not necessary that you have to install it inside a Hadoop cluster, right? It can be outside the Hadoop cluster also. See this picture? Your Hive Server 2 is outside the Hadoop cluster in this picture. Now, So like I explained, you sit, if you use CLI, directly it is Hive. If you use JDBC, ODBC, it goes through Hive server. But again, the sessions are handled by Hive server, but it is ultimately Hive, right? Now in the picture, it is very clearly shown that the Hadoop cluster is separate. That means Hive server need not be installed inside a Hadoop cluster. It can be outside. In most of the cases, it is installed outside as well, right? Now, inside the Hive architecture, you can see compiler, optimizer, executor. But how does Hive know where is the data? Or in other words, what about metadata? See, for any database or data warehouse or any system, you need to store metadata. What about the metadata? So in Hive, what happens? There is something called Metastore service. What is Metastore service? It is a service running to handle metadata. What is metadata? The definition of your table, the definition of your database, the schema of your table, all this is metadata. So you need to store the metadata somewhere, right? So that is what is handled by this Metastore service. By default, Hive uses something called embedded Metastore. Metastore. This means it stores the metadata in built-in Derby database. So what happens is that by default, if you are downloading and installing Hive, it comes with a database called Derby. Apache Derby. Apache Derby is a database, and it will use this Derby database to store the metadata. Clear? So that is called embedded Metastore. Embedded Metastore means by default, if you just download and install Hive, Hive will need some place to store the metadata. So it by default comes with this Apache Derby database, and it starts using Derby to store the metadata. You don't have to do anything. It will be all configured. Okay, so this embedded Metastore is good because you're saying that if I'm downloading and installing Hive, right, it will come with a database and it will store the metadata in the database. This is all good. But this Derby has a drawback. The Derby database is a single instance database. That means it will allow only one connection at a time. That means if you are using the embedded Metastore of Hive, only one person can access Hive. So that is a drawback. So what you can do is that you can configure your own database as metadata storage for Hive. Example, MySQL. So this is what we do in production. Meaning in production, what we do is that we will download and install Hive. Now we know that Hive will start working automatically because it will use Derby to store the metadata. But when it is using Derby to store the metadata, right, what happens is that it will allow only one connection at a time. Because Derby will allow only one connection. So we don't do that. What we do is that we will configure something like MySQL and ask Hive to store the metadata in MySQL so that multiple people can access Hive. The latest version of Hive allows updates, but all other versions of Hive by default does not allow updates because remember it is Hadoop. Hadoop is a write once read many system. In Hadoop there is no update process, right? You copy the data, you delete the data, you again copy the data. It is all writing the data and reading many times. But the latest version of Hive allows you to do that. It selectively can update it Okay, it can refer to the position of the block in the data node. So Hive can by default talk to Hadoop. It can understand where is your data, and accordingly it can do. So what you need to understand is that if you are practicing Hive on the Cloudera VM, if you are practicing Hive on the Cloudera VM, you are using embedded metastore. That means there is a Derby inside, and that is storing all your metadata. Very simple. But if you go to a company and start working on Hive, right, then the metadata will be stored in a separate database like MySQL. That is the difference. So two types of metadata storages are possible. So if a user write a query, the query will be accepted by somebody called a driver. The driver is not shown in the picture, but there is a driver. And the driver will pass it to somebody called compiler. Compiler will check with the metastore to get the metadata and compile your query. Then optimizer will optimize it and give to executor. Executor is your MapReduce, and MapReduce will run your query in the cluster. So step number 1, user writes the query, and the query comes to Hive. Okay, and first step is compiling the query. Now you won't simply compile the query because you need the metadata. So you will check with the metadata store about the metadata. Once you get the metadata, you compile the query, and there is a component called optimizer. It will optimize your MapReduce code so that it can perform better, and then give it to another component called executor. Executor is normally your MapReduce program. I mean MapReduce engine, and that will execute your query and show the result. There are two situations. Okay, again this is coming mostly from the practical aspect. If you're having a small Hadoop cluster, let's say you're having only 3 servers, I mean 3 data nodes, 4 data nodes, etc. And so it's a very small cluster, right? And normally this cluster will be accessed by only a couple of guys. So if you're sitting here, you have a computer, entire Hive will be installed here. Your Hive server will be running, everything will be running here. Why? Because it's a small cluster. There is no point in installing here and then connecting. You can install Hive, but usually, so I'm talking different use cases. I'm talking different use cases. In small Hadoop clusters, where you're having 3 to 4 data nodes and all, you will not do any heavy lifting. Why are you creating small Hadoop clusters? It might be for proof of concept. You're not actually running any production workload. So that means in this case, there is no Hive component in the Hadoop cluster. Entire Hive package is on your machine. Hive server, Hive CLI, whatever you call, anything starting with Hive is on your computer. Nothing is there in the cluster. Are you getting my point? Why? Why? Because either you or only your friend will be accessing this. And you don't need a separate client server and all, right? Because it's a very small cluster. So you install all the package on your computer, and then you can also install SQL client on your computer and create a JDBC connection. From here it will connect, etc., etc. But everything will be on your computer because it is a small Hadoop cluster. Now, what if it is a very big Hadoop cluster? In a very large Hadoop cluster, so this is a large Hadoop cluster, say thousands of data nodes. You will have something called a gateway node. Have you guys heard about this? What is a gateway node? Have you guys heard about this? No, I think. What is a gateway node? This guy will have connectivity with Hadoop. And it's a Linux machine. Imagine it's a Linux machine. Here, you will install everything. You will have your Hadoop client here. You will be having your, Hive server here, and maybe Pig. Everything will be installed here. And what you do is that if you're sitting here, right, you have a laptop. You don't install here. Maybe on your laptop, this is your laptop, right? So this guy is sitting here. This guy is sitting here. What he can do is that he can do multiple things. He can SSH to this machine. connect to this machine. So he log into this machine, and from here he can type Hive, he get a command prompt, start working on the cluster. Now another guy is sitting here, he has a laptop, okay, and here he has installed let's say SQL workbench SQL client. Now if he open the SQL workbench, it will connect to this, and from here it will connect to this, right? So what is the gateway node? Gateway node is nothing but is a server, okay? It acts like an intermediate between you and Hadoop cluster. In large Hadoop clusters, you will not be directly logging onto the cluster. You will never even see your cluster. It is strictly prohibited. You cannot access your cluster. All you do is that you connect to this gateway node. From here you can do anything. So if you prefer the CLI, what you do is that you log on to this gateway node using SSH. From there you are on the gateway node. You type Hive CLI, you get Hive CLI. Or if you're having a SQL client, okay, you give the details of this gateway, and this will connect to the gateway. From there it will connect to the large cluster. Right? So all the client packages are actually installed in the gateway node. That is my point. So you have two options. Either you log on to the gateway node. So now you log into the gateway node and open the command prompt and say hit Hive, you will see the Hive shell. You start working. Or if you're having a SQL workbench, your Hive server will be running on this gateway node. Okay, SQL workbench will connect to Hive server and to your cluster. Interface of Hive. Just type Hive and hit enter. And this is the Hive shell. So this is the command line interface of Hive, the interactive shell of Hive. What you see is Hive shell. Now, once you are in the Hive shell, most of the commands that you type need no introduction, because the commands are SQL commands and most of you are familiar with SQL, right? For example, I can say first command, probably if you log on to any of these systems, the first command you will probably type is show databases. You can see all the databases that got created. Now, the best way to understand Hive is to start working with Hive. So what I'm going to do, I'm going to say create database, let's say Dell, and if I do a show databases, it will be there. There is a database called Dell. Now if you want to use it, just say use Dell. So when you say use Dell, the database has changed. So now you're using the database called Dell. Fine. So far, so good. Now, these are regular things, right? Now, let's take a sample scenario and see how we can use Hive to solve a problem. Rather than just speaking about Hive, right? Let's take a sample scenario. So let me show you the data that I'll be working with. Yeah, so on my desktop, I have a file called transactions. Can you see this file? It is called txns1. It's a transaction data. If I open this file, this is how the data looks like. Just to give you an idea, right? Now, if I have to explain this data, let's pick one record. So this is one record so that I can explain to you. As you can see, every record is comma separated values. So this has some structure. The first column, so this is a transaction data from a sports store or a retail store. So first column is transaction ID, which is 4. Then you have date of transaction, 17th December 2011. Then you have something called customer ID, 4002613. That is the customer ID or the customer number. then the amount spent, which is $98.81, and then the category team sports, the item field hockey, city Nashville, and the state of Tennessee. It's a credit transaction. So this is how your transaction data looks like, line by line. Multiple customers have purchased items from a sports store. That's it. So it's a very big data actually. I mean, there are a lot of lines in this data, right? So this is one file. Now, I also have another file here called customers. So if I open this file, this is my customer data. For example, if I pick one line or one record at a time, first column is customer ID, okay, which is 400015. Then you have first name and last name, Julia Desai, aged 49, profession is musician. So we are having two set of data. One data is the transaction done by the customers. The second data is the data about the customer. Their name, customer ID, age, and what you say, profession. So I'm having two set of data. And as you can see, the customer ID is common in both the data set, right? Now what I want to do is, I want to analyze this data. What sort of an analysis? What I practically want to do is that I want to understand how much money is spent by youngsters in my store and how much total amount is spent by middle-aged people in my store and how much amount is spent by old-aged people at my store. So basically, I want to classify the customers into three groups, say 20 to 30, one group, 30 to 50, another group, 50 above, another group, and I want to calculate the sum of amount spent by them. I want to use Hive for this. So let's look at how we can do this. So as a first step, what I'm going to do is that I'm going to create a table. This is the syntax to create a table. And this should not be a surprise to you if you already know SQL. I'm saying create table called, this is my table name, transaction records. And this is my schema. Very simple. Transaction number, date, customer number, amount, category, product, city, state, spent by. And Hive imposes schema, which is very similar to, and the data types and all are very similar to what you deal in day-to-day life. Like it supports in, string, double, float, everything almost, right? So I have given the schema to my data, right? Then I say row format. I am expecting my data in row format. That means by default, Hive will identify a row and using new line character, it is going to separate every record. Delimited fields terminated by comma, meaning my individual fields are comma separated. If you give semicolon here, your input data should be having semicolon. Then I say stored as text file. By default, Hive stores the data as text file. Now you can say sequence file or any other format also if you want, but if you don't type text file also, it is going to store it as text file. This is the for syntax. If I hit enter, Hive says OK, which proves the data is created, right? I mean the table has been created. Now, the next point, I have the table. How do I load the data to the table? Now, there are multiple ways to load the data to a Hive table. I'm going to first show you the common way. That is what everybody does. So, where is the data? The data is on the desktop of my Linux machine. I mean, the data is in my local file system. So what you can do is load data local in path /home Cloudera. So this is the path. Desktop. Into table. Tx. That is how you load the data. You can actually do insert, right? But typically in data warehousing, you get bulk data to load. So you will be getting huge amount of tables and text files which you want to load it into this place. So usually you will not say insert. Usually you will dump the data like this. So what I'm saying load data local in path. This means my data is in my local file system, and this is the path of my data into the table transaction records. That's it. So now if I do a select star from the table, say limit of 20 or something, I should be able to see the data. See, I'm able to see the data because I have loaded the data to the table, right? So now the data is also in the table. But what is happening in Hadoop? Behind the scenes, what is happening? That is one question, right? I will show you what is happening behind the scenes. Whenever you install Hive on any platform, what Hive does is that it will create a folder called warehouse in HDFS. So if I do an HDFS, DFS-ls, you see this? Whenever you install Hive, Hive will automatically create this folder called warehouse in Hadoop or HDFS. The folder name is warehouse. Now, if you check what is inside this warehouse folder, you see all the databases you have created. So this is our database, del.db, right? So whatever databases you are creating, is actually stored inside this warehouse directory. Whenever you create a database, okay, the database gets created in this path, user Hive warehouse, and then the DB, what you create. Now, the DB is just a folder in Hadoop. DB is just a folder in Hadoop. Hue is a web interface to your Hadoop, nothing else. So in Hue, I can just go to browser and I can just see, rather than typing HDFS, DFS, I can just come here and see what is the files in Hadoop. When you install Hive, it creates a folder called warehouse. So this is the warehouse folder, right? Can you see the warehouse folder? So it creates a folder called warehouse. Inside this warehouse folder, if you open this warehouse folder, you can see all the databases you have created. So this database called del.db is nothing but a folder in Hadoop. You created a database and you think it is a database. It's not a database, it's just a folder. See del.db. If I open this folder, what you see? Another folder called transaction records. The transaction records table you created is just a folder. And if I open this, can you tell me what you see here? The file that I copied. So look at the table structure. Look at here. Your database del.db is just a folder. Transaction records is another folder. Inside that you have the file. This is what is happening in Hadoop. So when you are loading the data into a Hive table, it is just copying the data from Linux to this folder in Hadoop. Is this clear to you or not? Of course, you use a command load data local in path, but what is happening behind the scenes is that The data that you are inserting into the table is just copied into this location in HDFS. And if this data was very big, it will be divided into blocks and all, just like regular Hadoop file. This is where your data gets stored. So I can also show this from command line. So if I do warehouse, then del.db, what will I see? I see another folder called transaction records. And if I again say txn records, I will see the file. So that is why I'm saying Hive is just giving you a projection. The actual data is just lying in Hadoop, right? Now what I will do is that, okay, I will create one more table because we have the customer data to be stored. I will say create a table called customer, and this is having customer number, first name, last name, etc. So another table, and we will load the data. So the data is into the table called customer. Right? So now the data is loaded into customer, but you will be wondering, so far I have not seen any MapReduce program, right? So I was telling you that if you query the data, you will see the MapReduce job and all, but so far I have not seen anything because you have not actually ran a query. So let's say select count star from transaction records. So this is a proper query. So I'm doing a select count star from the table. So basically I want to know how many rows are there. If I hit enter, it's going to fire a MapReduce job. Can you see this? Because it's a proper query, it cannot just show the result. It's going to launch a job and create a jar file. And here is the result, 50,000. So the answer is 50,000. The result of the query is 50,000. How did I do it? I just wrote my query and hit enter in Hive, and it automatically launches an equivalent MapReduce job to show me the result. And I get the result here. Now let's analyze this further. So what I want to do is that I'll be creating one more table. So I'm going to create a table called out1. Okay, this table has customer number, first name, age, profession, amount, and product. So basically my idea is to do a join operation. I have a customer data, I have a transaction data. Both the data has a common column called customer ID. So my idea is to do a join operation, a simple inner join operation. And the results of the join operation has to be stored on a table. So I have created a table already. So this table is called out1. And how do you do a join operation in Hive? Very simple. Insert overwrite table out1. So out1 is the new table we have created. Select a.customer, a.first name, a.age. So if you look at the syntax of the join operation, it is exactly same as your normal SQL join operation, right? If I hit enter, it's going to launch a MapReduce job. So now the join is over, and if I do a select star from out1, this is the result of our join. And if I do a limit of 20 or something, see, this is the result of the new table. In the new table, if you see, this is the result of the join operation. So you see, you have customer related data and transaction related data. This is very simple, okay? I'm just following the same logic of SQL. Only difference here is that, it is converting it into MapReduce job, right? Now what I can do is that after this, I will create one more table. I'm creating a table called out2. Now what I want to do is, see, now I have done the join operation, but I want to classify my customers, right? My customers are having different age. So I'm having a column called age and I want to classify my customers. How can I do that? Very simple. If you look at here, insert overwrite table out to. That means the result will be in this table, which we created in the last step. Select star comma case. You see, I'm opening a case here. And what is the case? When age is less than 30, then it will be marked as low. When age is between 30 and 50, middle. Greater than 50, old, else others, end. So what this query will do, it will pick all the rows from my previous table, look at the age column, and based on my criteria, it will mark every record as low, middle, old. You hit enter, it's going to fire a MapReduce job again. So every query will fire a MapReduce job. You don't have to worry about that. So you can see the map 0, reduce 0, etc. And now it's over. So if I do now the query is over. If I do a select star from out to, if I do a limit of 20 or something, you see every record is now having a category, old, middle, old, etc. Right? So now I am able to classify the customers. Now all I need to do is very simple. I will create one more table. I will do a group by query. So what I'm doing here is very simple, guys. I'm saying insert override table out 3. So out 3 is the latest table I have created. Select level. So the level column will have low, middle, that age classification. Sum of amount from out to group by level. So it's a very simple group by query. The result of this query will have your final answer. So the table name is out3 and the query is over. If I do a select star from that, I will have the final answer. See, this is your final answer. So the youngsters are spending this much amount, middle-aged people are spending this much amount, old-aged people are spending this much amount. So this is how you start working on Hive. There are two types of tables in Hive. There is something called managed table. There is something called external table. And by default, any table that you create is a managed table. So I will tell you what is the difference, okay? But there are two types of tables in Hive which you can create. I mean, two types of tables. There is something called managed table and there is something called external table. Now, what are these things? By default, any table you create is called a managed table. So what is that? How do you know that? If you go to Hive, you can say show tables. And we have a table called transaction records. If I say describe formatted txn records, if I type this command, describe the table, it says it's a managed table. Table type is managed, and look at the location of the table. Managed table means the table is managed by Hive. That means this table is stored under user Hive warehouse and you cannot change that as well. That is called a managed table. So if that is managed table, what is an external table? In Hive, I can say what I can do is this. I can say create external table. So when you want to create an external table, I will tell you what is an external table. You have to say create external table. Well, the syntax is not correct. Let me add one more thing. location slash user slash Cloudera slash user Cloudera. I think it is user Cloudera. Then I can say my customer, something like this. Okay, let me type this first, then you will understand. Yeah, so this is the proper syntax, guys. So what am I doing here? I'm saying create external table. So whenever you're creating an external table, you have to specifically mention that it is an external table. Otherwise, you just say create table, it's going to be a manage table. So I say create external table, and this is the table name. And if you look at the schema and row formats, they are all same. There is no difference in the schema or the format or anything. Only difference, I'm saying location user Cloudera my customer, meaning this is the location in Hadoop. How do you know that? So once you create this table, if you go to your Hue, you go to user Cloudera, there is a table created called my customer. Can you see this? This table is just created and there is no data inside this. Now what is the advantage is that, so now I created a external table. If I do a select star from this table, txn records 2, there is no data because I just created a table. I didn't fill it with data. If you want to fill it with data, all you need to do is very simple. Go to the folder mentioned in the external table, that is my customer, copy the data to that folder. Now I just uploaded this data to this my customer folder. Can you see this? In the my customer folder in Hadoop, I just uploaded this data. Now if I come back here, again I do a select star, do a limit of 20, I have the data. So what is the difference between a managed table and external table? In managed table, which is the default table by the way, when you create a table, the table is always created in user Hive warehouse, that location. And then you manually load the data to the table. External table means when you create an external table, you are mentioning the location of your data. Look at this line. You say that the data will come from this folder and whatever data you dump in this folder will be visible in your table. Very simple. What exactly is the difference between a managed table and an external table? Is the difference only the location? Yes, the difference is only location, but the real question is, where will you be using a managed table and where will you be using the external table? Now I can show you practically. Have a look at here, guys. Now, if I do a show tables, there is a table called transaction records. This is a managed table. I can say drop table txn records. So what am I doing? I'm dropping the table called transaction records. That's a managed table. What will happen to the data in this managed table? It will be deleted. Why it will be deleted? Because when you drop a table, that folder is deleted from Hadoop. Remember the folder structure. The data is inside that, right? So that means if you drop a managed table, the data is gone. But if I do a drop table txn records 2, that is an external table, the table is gone, but Cloudera and the folder is my customer, the data remains there. This is the difference. This is the difference. If you drop a managed table, the table goes, the data also goes. If you drop an external table, only the table goes, the data remains the same. So if you want to share your table with others, let's say you're working in a project, okay, you create a table and you think that you want to share the table with others, and you suspect accidentally somebody may delete your table, create a external table, because if somebody accidentally drop your table, still your data will be safe. Otherwise, create a managed table. How to use how to use a Beeline. So Beeline is the new CLI, and by default, if you are using Cloudera VM, it will have Hive Server 2 running, and the default port number it is 10,000. You can check the documentation to ensure that. Now, if you want to connect with Beeline, all you need to do is you have to start Beeline first. Okay. This is how you start Beeline. You will say user live hive bin Beeline. Basically, this is a location where Beeline is installed. It may differ in different distributions, but in Cloudera Hadoop, it is always right. So now you see the Beeline CLI, but here if I say show tables, it's going to throw an error. When I say show tables in Beeline, it's going to throw an error. It says no connection. Remember, Beeline is a client. It need to connect with Hive server. Beeline is a client. Now you see the difference, right? When I'm opening Hive, if I just hit Hive, I am accessing the Hive entire package. It's not a client only. But when I say Beeline, it's a client. So in Beeline, when I say show table, it says no connection. I can't connect to the server. If you want to connect to the server, what you need to do is this, guys. This is the connection string. You can use the same in your JDBC or ODBC or whatever you have. This is your connection string. Connect JDBC Hive 2. Hive 2 stands for Hive server, right? Localhost, that's the port number. Username, password by default nothing because I'm running locally, and JDBC Hive driver. So it will connect, right? So now I am inside this. Right now, if I say show tables, show databases, it will list all the databases. So this is how you start Beeline. So you will say user lib hive Beeline. So that will start Beeline. Beeline is your client. And when you say show tables, it won't show anything because it need a server connectivity. And this is the connection string. So you will say connect with JDBC Hive server 2 localhost running in localhost, and the port number, username, password, hit enter, it will connect. Okay, once it is connected, you can type your regular commands. So I am typing, where is the command? Where is the command? Show databases. So this is the command I type, and here is the list of the databases. And the command line is pretty much similar to your Hive CLI. So this is how you start working on Beeline. This is Beeline. Okay. Now, if you want to quit Beeline, just say exclamatory mark Q. This is the command to quit. Very important. Exclamatory mark Q will quit Beeline. So now I am back. Right. So that is how you connect from Beeline client to Hive server 2. You can also download Beeline client on your desktop or something and make a connection to the Hive server. Now, if you don't want to type all the commands and all, you hate the commands of creating a table and all, what you can do is come to Hue. Okay, then what I'm going to do is that let me show you the data I'll be working on. Here, okay, there is a data called healthcare sample data. Now this has patient ID, patient name, patient mobile number, date of birth, hospital data, email address, social security number, the disease, diabetes, fever, cold, blah, blah, blah. So this is a sample data that I'm using. What if I want to upload this data into Hive and query the data? Basically, I want to get a list of all the people who are having cold. So if I want to do that, you can of course use the command line, but you can also use the GUI. Let me show you that. Go to Hue, go to this data browsers. There is something called Meta Store Table. Click on this. Once you click on Metastore table, okay, it will allow you to select the database. So I'm going to select our database. I can select this database. I can say create a table from a file. I can give a table name test table. Okay. And then I can say select the file from where you want to create a table. So which is this healthcare data. Say next. It's going to automatically look at the data. It will ask you, hey, is this how your data looks like? Yes. I will say next. And it is also automatically going to select the data type. I'm going to say create table. So this will create a table from the file that I have uploaded to Hadoop. No need to type any statement or anything. Right? So going to create a table. Now once the table is created, you can query the table from the GUI. You don't have to use CLI. Let me show you that. What you can do is you can go to this query editors. There is something called Hive. Can you see here? You can go to Hive. In Hive, you have to use the database. I have a database called test table. I can select this table, right? So there's a table. So I can say select star from test table where column number 7 equals cold and then execute the query. So this will run the query in the GUI and show me the result. Can you see this? Right? And I can create nice charts and all if I want. Right? I can create like charts and all. See, stacks and groups and everything I can create if I want. Basically, what I'm telling you is that you can run queries from the GUI also. Partitions in Hive. So what exactly is partitions in Hive and why are we doing this, right? What's the idea behind partitions in Hive and what we are supposed to do? So just imagine that you are working in a project which uses Hive. Okay, so you are in a project which uses, of course, Apache Hive, and you're happy you're working on Hive and everything is going fine. Now what happens is that let's imagine that your manager comes to you and say that, hey Raghu, do one thing, create a table for me in your Hive in which I want to upload all my sales data. So what I did, I created a table, create table, sales data. I created a table called sales data because my manager says he has to upload some data related to sales. So I created a table called sales data with some schema, some columns and all, whatever we have. Now imagine you are working on a managed table. So for the time being, we assume that we are on a managed table, and by default, what happens is that if you create this table, the table will be stored in user Hive warehouse, and let's say our database is called newdb /sales data. If you create a table called sales data, this will be the location by default. So this is the basic stuff, right? So whenever you're creating a managed table, the table's location will be this. Now what happened is that your manager told you that, hey Raghu, do one thing. I have some data. Why don't you load the data to the table? So your manager gives you a file and asks you to load that into the sales data table. No big deal, because usually you know how to load the data. You will say load data local in path and then load the data. When you loaded the data, so the manager says, hey, this is January month data. So you loaded a file called january.txt. Very simple. I have created a table called sales data. I have loaded a file called january.txt. This contains all the sales transactions in the month of January. Very simple. So you are happy. Your manager is also happy, right? Yeah. So then what happened is that, you keep on working in the project, and the next month your manager comes to you and say that, hey, Raghu, we have some more data, so this data is from the month of February. Why don't you load the data to the table? So you end up having, so now the file is february.txt because this is the February month data. However, since this is getting loaded into the same table, this will be the structure. Now inside the sales data folder, now you have two files, January and February, right? So probably I will write it like this so that it's easy for you to understand. I will say like this. Hmm? And then your manager says, hey Raghu, I have some more data. I have some more data. March.txt comes. Then what happens? April.txt comes. Then what happens? May.txt comes. And June.txt comes. So what is happening here? Every month you are getting the data, right? Every month you are getting the data and you are loading the data to the table because you have a table called sales data. But if you look at the way in which the data is stored, what you can see is that these all different files, January, February, March, April, May, June, all are inside the same folder called sales data because that is your table name, right? So, okay, so you might think that that's fine, but what is the problem? Now imagine, okay, you are writing a query like this, okay? Just imagine that you want to write a query something like this. Select star from sales data table where month equals, let's say, April. I'm just giving you an example, okay? So let's say you want to query the table. You want to query the table. So what is the query? You say select star from the table where month equals to April. Means you want to see all the data from April month. Now look at the problem you have. Hive by default doesn't know where is April month data. So what Hive will do, it will come to this folder called sales data. It will first scan this entire January.txt, then scan this entire February.txt, then March.txt, then April.txt, it finds some match, again May.txt, again June.txt. Meaning your entire data is scanned for this single query and your queries will be really, really, really slow. So the problem we have is we have a table. So table in Hadoop is like a folder, right? And you keep on loading the data. Every time you load the data, it's going to store as a file. So that means inside a single file, now I have inside a single folder, now I'm having 6 files. January, February, March, April, May, June. And if you write a query, Hive doesn't know where is the data. It is going to scan all the 6 files. It is going to go through all the 6 files to show you the final result. And so you imagine you keep on adding files every month, data every month. If your table has, let's say, 100 different files, Hive has to scan this entire files before showing you the output of the query result. And obviously your queries will be really, really, really slow. So you are not actually saying where is the data. So that is a simple problem. And Hive has to scan the entire files to produce result. So ideally your queries will be slow. It will be really, really slow. So the question is, what can I do in such a situation? I don't want my queries to be slow. I want my queries to be faster. That is where your concept of partitions come into picture. So there is something called partitions in Hive. So what exactly is partitions? Partitions means you tell Hive to divide the data based on a column. What is a partition? You're telling Hive to divide your data or segregate your data based on a column. For example, what I can say here is that I can say, hey Hive, look at what I'm writing. Partition my table based on the month column. So this is what you can tell to Hive. So I can tell Hive, hey Hive, do one thing. Partition my table, okay, based on the month column. If you tell this, what Hive will do is that it is gonna look at, now once you write this, it is gonna look at the whole data first. Then it is gonna look at the month column in the whole data, right? Now obviously in your january.txt file, the month column will be what? January. What Hive will do, it will create a folder called Jan and place this file inside that. Accordingly, it's going to create something called Feb and place it here, and March, place it here, sorry, and April, place it here, May, place it here, June, place it here. So when you tell Hive that, hey Hive, I want to create partitions and I want to create partitions based on the month column, what Hive will do is that it's going to pick the column from the whole data and understand how many values are there. In my example, there are 6 months data. It's going to automatically create 6 folders: Jan, Feb, March, April, May, June. All the January month data will be copied into this folder. All the February month data will be copied into this folder, etc. So now if you write the same query, select star from sales data where month equal to April, Hive will scan only this folder because it knows April month data is inside a folder called APR. Your queries will be much faster. This is called partitioning in Hive. A partition is nothing, it is a division on your table actually. So when you are saying create partitions, what is happening is very simple. Based on the partition column, those many folders will be created, and whatever criteria matching with that folder, that data will be moved into that folder. Very simple. You have to understand one more thing. So I will show you the data maybe, so then it is easy for you to understand. This is the data that I will be using for partitioning. If you take one record of this data, you will understand what is this data. So let me show you what is the data first, and then I will explain what I'm going to do. First, let's analyze the data. Look at here. This is one record. This is one record. So first name Gerardo, last name Vodka, then 69206 Jackson Avenue, that is the address. Australia, that is the country. Then the state, primary phone number, secondary phone number, email address, and website. That is the data. Now if I scroll down, let's say this data. Look at here. Angelicia Lovero, that is the name. The address is 689 S Steel Street, 1887 CA, California. I think California, right? And so then you have the other details. So basically, the data actually contains users' names. Okay, so I will just show you the last part of the data. Let me just show you the last part of the data. Yeah, this is US. So if you look at here, Gilma Luco and the address US, again for primary phone number, secondary phone number, email address, website. So that is the data that we are going to do. Now, there are two types of partitions. There is something called static partitioning. Static partitioning, and there is something called dynamic partitioning. Now, what is static partitioning? What is dynamic partitioning? In static partitioning, you have to manually create the partition and load the data. In dynamic partitioning, Hive will automatically detect your data and create the partition. So you will naturally think where this is applicable, because dynamic partitioning seems to be really good, because in dynamic partitioning, Hive is automatically going to create my partitions. Then why should I use static partitioning, right? So let's say you have a data like this, Raghu, comma, the phone number, and then you have email address. Then you also have Ram, something, okay, ram@abc.com. Okay, now you also have some more data. Let's say Tina, some phone number, tina@abc.com. Now then you have Ajay. Okay, some phone number for Ajay, ajay@abc.com, comma. So let's suppose you are having this data. Now Raghu and Ram are in India. And Tina and Ajay are living in USA. But you do not have a strict column for India and USA in the data. See, in the data, all I have is name, then phone number, then email address and website. I don't have a country. But I know that Raghu and Ram belong to India and Tina and Ajay belong to USA. In this case, what I do is that I will manually create two partitions, and partitions will be India and USA, and load the first two files in India and last two files in USA. This is static partitioning. Did you understand the use case of static partitioning? Static partitioning means you are getting the data, you know that the data is segregated. You know that half of this data is belonging to country India and half of the data belonging to country US. But that information is not present in the data, right? So what you do is that you create static partitions. Static partitions means when you are loading the data, you will ask Hive, create a partition called India, put this data there. Create a partition called USA, put this data there. Then you can query the data saying select star from my table where country equal to India. It will definitely query this partition. So this is like you're defining a column while loading the data. Now I will show you partitioning. That will be the best way to do this. So what I'm going to do is that I'm going to connect to the VM first. Okay, then let's see how partitioning is done. So now what I'm going to do is that, okay, I'm going to launch Hive first. Okay, first thing I'm going to do is that I'm going to launch Hive. So, and we have the data. I just showed you the data, right? So the first thing I'm going to do, I'm going to demonstrate static partitioning right now, right? Show databases. We have to take a database. Okay, so remember Hue is your web interface, right? So first thing I'm going to show you is how my folder structure looks on Hadoop. Now, so I'm going to go to my root directory and user directory, and we have the Hive directory. There is the warehouse, and there is the Dell DB, and inside the Dell DB I have these folders. Now what I'm going to do is I'm going to say create a table called partitioned user. Now you can give any table name, and look at how I'm creating a partition table. This is my schema. Okay, after the schema I'm saying partition by country and state. Look at here. So whatever columns you are using for partitioning should be outside your schema definition. So when you are creating the table, you say create a table, give the schema, no problem, that's all fine. But I'm saying partitioned by country and state. That means I'm telling Hive that, hey Hive, I'm creating a table and this is my schema and I'm going to partition using two columns, country and state. If you hit enter, it will create a table. But look at here. If I refresh my hue, this is the table we created, partitioned user. If I go inside the table, there is no partition. There is no partition. So when you create a partitioned table, there is no divisions. It's a normal table only. Can you see this? I just opened this table. This is the table partitioned user. If you open this, there is nothing inside that. Now, how do you create static partitions? Very simple. In order to create static partitions, what you need to do is, let me show you the data. I will duplicate this session. Root sudo su cloudera. Okay, I'm going to use this file called static. Let me show you the file. Now this file has 3 rows of data and I am going to load this file into my table and create partitions. Now I completely understand that this file, is copied from the original file that we had, but this is the file which I will be using for demonstrating partitions, right? If you look at here, it has only 3 records as of now, right? So you have the name, then you have the address, right? And then you have the phone number and email address, website. That's it. So what I'm going to do is, I'm going to say load data local in path. So I'm going to load this folder into this table, partition country equal to US, state equal to California. This is how you're creating static partition. I already have a table and that table has all the schema. Now I'm saying load this file, but while loading this file, create a folder called US. Inside that, create a folder called California, then put the data. Now US is my country, California is my state, the file will be inside that. I created the table here, then I loaded the data where I said country is US and state is California, right? Now I will show you how the folder looks like in Hue. If I refresh my Hue, if I go to Dell DB, there is this partitioned user. Inside that there is a folder called Country America. Inside that there is a folder called State California. Inside that my data is there. And this is the data. Now if you look at the data, there is no country column, there is no state column in the data, but I created this so that it falls here. Now if I query the data, I will write a query where country equal to US and state equal to California. It will land on this data and query this so that it will be faster. So these are the commands are used. First you create the table, give the schema, define your partition columns outside the schema. So this is what I'm doing, right? Define the partition columns outside the schema. Then you load the data. While loading the data, okay, the data you should say this data is belonging to which country, which state. Very simple. You have to give a country name and a state name. Okay, now let's discuss dynamic partitioning so that you guys are familiar with this, right? Now, what I want to do is, before you do dynamic partitioning, you have to do a couple of things. First of all, you have to enable dynamic partitioning. Now I will show you how to do dynamic partitioning. So what am I doing here? See, by default, Hive has static partitioning enabled. That means Hive will not allow you to do dynamic partitioning. So that is why I'm typing this command, set Hive execute dynamic partition true. That means it will enable dynamic partitioning. I'm also saying that maximum dynamic partitions per node is 1000. That means maximum partitions created will be 1000. You can give more numbers if you want. It is up to you. I just use 1000 so that it sounds good. Okay. You are also saying that the partition mode is non-strict. Okay. You are having something called strict mode and non-strict mode. Okay. So I'm just saying that, partition mode non-strict. Now, in order to do dynamic partitioning, like what I'm going to do is that I'm going to show you dynamic partitioning with the same set of data. Hive will allow both static and dynamic partitions. As of now, I have enabled dynamic partitions. By default, it has only static partitions. Okay. Now let's look at what I'm going to do. It's very simple, right? I'm going to create a temporary table. Now the temporary table concept in Hive is exactly similar to your normal temporary table. Okay, so how do you create a temporary table? Temporary tables are valid only till the session last. You say create temporary table, and this time I'm not doing any partitioning. You see, I'm giving the complete schema. Look at here. I'm creating a normal temporary table. No partition, nothing. Just a simple temporary table, and this table is called temp_user. So I'm creating a table called temp_user, normal temporary table, no partitioning, nothing. Once I create the temporary table, I want to load the data. So let me load the data. Now this time, what data am I loading? I'm loading this file called customer data.txt, and that is this file. This file has country and state column. We are working on this file. This file has a column for country and state. Okay, so I'm creating a file. Then I'm creating a table, a temporary table. Then I loaded my data into the temporary table. Now, as the first step, I just want to write a query and see whether my query is taking time or not. So what I will do, I will write a very simple query. I will say select first name comma phone 1 comma city from the temporary table, where country equal to US and state equal to California, order by city, limit 5. It's a very simple query, but the only condition is that I'm using country and state just to see or just to demonstrate how much time it will take if I'm not partitioning my table. So right now there are no partitions. Okay, so let's run the query, and the query runs, of course, and let's see how much time it is taking. Okay, so this time the MapReduce job is over and it took 85 seconds. So we will see whether it is faster. Now there is also one more setting. I'm running it on a VM, and even if I do partitioning, it may not have much of an impact, but let's see. Now let me show you how to create dynamic partitions. If I go to my Hue, I go to this del DB, okay, and okay, so this is my del DB, right? Now what I want to do is I want to create a partition table. So what I will do, create table called partitioned user 1, okay, and this is the schema of my table, right? Partition by country and state and stored as sequence file. Now this is optional. You can store it as text file or sequence file or anything, that is optional. But this is the same command we used for creating static partition. When I was creating a static partitioning table also, I used the same command, but here the difference is that the data already contains the state and country column. Now see what I'm going to do. So I created a table called partitioned user, right? Now see what I'm going to do. I'm going to say insert into table partition underscore user 1 partition country comma state. So what I'm telling Hive is that, hey Hive, I want you to copy all the data from my temporary table and load it into this new table and partition it with country and state. I'm not going to tell you which country, which state, you decide, because already the columns are present. Now let's see what is going to happen. So see, now what Hive is doing, it will take the data from your temporary table, look it into the country state columns, identify the countries, identify the states, create those many folders and put the data accordingly. I will show you this now. Look at your screen very carefully. You will be able to see Hive creating these folders. So now it is creating the partitions. You will see that right now. Just wait for a moment for that to pop up. Can you see the loading partitions, loading partitions, loading partitions? Can you see that? Country, country, state, country, state. Can you see it creating these files and folders? And done. Now if I look at my hue, the table is called partitioned underscore user 1. If I open this table, there are 5 countries: Australia, Canada, UK, US. Okay, I mean last one you leave it, there are 4 countries. If I open the folder called country US, all the states are created wherever you had the data. If you open any of these states, you will have a file that will have only that state data. Of course, you are not able to see the file in the proper format because it is storing it as a sequence file. But this has the state related data only if that is matching with here. So now you can see that, it is creating countries, and then inside country it is creating states also. And inside that the file is created. So this is dynamic partition. Now we will just see whether the query is faster right now. Okay, so what I will do, I will write the same query on the partition table, see whether it is running faster. So I'm writing the same query we ran last time. It took 85 seconds in the last time. Now the same query but on the new table, see what is going to happen. It might not be that much difference, but I guess there will be some difference. See, time taken 41 seconds. Can you see this? Last time without partitioning it was 85 seconds. Now your query is taking only 41 seconds. That is the impact on the query time when you are using partitioning.
Just a quick info guys, if you want to become a certified Big Data Hadoop architect, Intellipaat offers you a complete Big Data Hadoop architect course which covers all the major concepts. So for further details, check the description below. So this brings us to the end of this session. If you have any query, please do comment below. We'll reach out immediately. Thank you.